All right. So for this lab quiz, we'll be focusing on a Pearson's R correlational analysis, which again is quite simple, and interpreting its significance. So we've got a series of variables, and we're going to do a bunch of Pearson's R's to enable us to look at different sorts of correlations. So here's our prompt. So the data provided depicts some hypothetical information about a sample of 20 undergraduates. The variables include IQ, score on a happiness measure, score on an anxiety measure, and score on a meaning in life measure. So we're going to use SPSS to do a series of analyses. So first, just to keep us refreshed on how to run our descriptives, we're going to compute the descriptives, mean and standard deviation, for IQ, happiness, anxiety, and meaning, since those are all quantitative variables. So that's very easy to do, so let's just refresh your memory. Go to Analyze, Descriptive, Descriptives, and you can put all 4 variables in here at once. You don't need to do it one at a time. In fact, I would recommend saving time and doing them all at once. For mean and standard deviation, you shouldn't need to select anything else, so you can just go ahead and hit OK. And this is my descriptive analyses for my 4 quantitative variables. To fill out your answers, do please pull out the mean and standard deviation value, because again, this is meant to make sure that you are not just able to crunch numbers in SPSS, you're able to pull out the key information that you need from the output. All right, so next we're going to do our primary correlational analyses. So create a correlation matrix, including the IQ, happiness, anxiety, and meaning variables. Select the Pearson's correlation coefficient, two-tilt test, and flag significant correlations. You're going to need to report the Pearson's R and P level and be able to tell which ones were significant. So here's how you do that. You go to Analyze, Correlate, Bivariate. Bivariate just means 2 variables. There's other kinds of correlational coefficients, but this Pearson's R is the only one we're going to learn about since it is the most useful. Now, you don't need to run your correlational analysis 1 pair at a time. You can put as many variables here at the same time as you want. So go ahead and select all of them and put it over into variables. This is still going to run bivariate analyses. What's going to happen is that SPSS is just going to create all combinations of all of these variables, and it's going to give us a separate correlation for each. So it saves time to just do them all at once, but you're going to need to be able to look at and interpret the output. So you don't need to change any of these settings, Pearson's, two-tailed flag. Okay. This here is what we call a correlation matrix. There's a few things I'd like to point out about actually understanding and using this output. 1, notice that the variables are listed downwards and sideways. This means that to find the correlation between any specific pair of variables, let's say you want to know the relationship between happiness and meaning in life, you find the first variable, you find the second variable, there it is. This value here in all of the rows labeled Pearson correlation is your R value. The value right below it in the row labeled sig two-tailed is your P value. These are the 2 primary numerical pieces that you report when you're writing up a correlational analysis. You write up your R with its unique P value. So that's basically how you look at the correlation matrix. There's a few other things I want to point out. One is that you see this diagonal here that just says 1. The reason is because, like I said, the variables are listed downwards and sideways. That means that this box here represents the correlation between IQ and IQ. That's obviously going to be a perfect correlation. It's a variable being correlated with itself. That is inherently useless information. So this entire diagonal is full of unnecessary information. You can just disregard it. You might also notice that each half above and below that diagonal is a mirror image of itself. Again, that's because the variables are listed this way and that way, meaning that to get the correlation between happiness and IQ, that information is here in that box, and the same information is here. Essentially, it's because this gives you the correlation between happiness and IQ. This gives you the correlation between IQ and happiness. The same thing. It doesn't matter in a correlation which variable is X and which variable is Y. Doesn't matter whatsoever. So, in order to pull out the correlations, you only need to look at one half of the matrix to get all the information you need. Right? There's this correlation between IQ and happiness, between IQ and anxiety, IQ and meaning. Happiness and anxiety, happiness and meaning. Anxiety and meaning. That's it. That's all combinations. All of the information down here below the diagonal is redundant and unnecessary. Okay? So that's basically how you interact with the matrix. You need to find the correlations that you're interested in, and you need to pull out the R value and the P value. Does anyone have any questions right now at this point? Okay, and then I think lastly, while I'm here, I'll point out that the flagging significant correlations bit makes your life easier because it provides asterisks that tell you about the significance level. So any correlation that you see that has an asterisk next to it, that little star, that's a significant correlation. You want to go through and you want to identify which one of those have stars next to them. But if you follow along for the hypothesis testing lecture, it is also true that any p-value below 0.05 will be flagged as significant. So if you notice, all of the Pearson's R's that have an asterisk, that p is less than 0.05, less than, right? So the p-value here, 0.01, less than 0.05. This p-value, 0.058, it's close, but that's higher than 0.05. One thing, promise last thing I'll point out here. One is that if you look here, this correlation between happiness and anxiety, you see how that p says 0.000? A p-value can never be 0. There is no such thing as a 0% error rate. Anytime you make any conclusion ever, there is a chance you will be wrong. So there is no such thing as p equals 0.000. This is just because SPSS runs out of decimal rooms after 3. To write this up, please, I implore you, do not write that p equals 0.000. The way that we write up this p-value is to say that it is less than 0.001, because that's really what it means. There is no such thing as p equals 0, because there is no such thing ever in life as a 0% chance of making a mistake. So if you ever catch yourself writing p equals 0, stop and write less than 0.001. I beg of you. Please. Please. Okay. Again, any questions at this point?
Dr. Roylance?
Yeah.
About the significant level, can I use 0.01 since it is the label? What it says, correlation significant at level like 0.01?
Yeah, so the reason it says that is because all of the correlations in here made it past this 0.01 level, right? So this one made it past 0.01, this one made it past 0.01. Whenever you have a significance level that gets to 0.01, SPSS flags that as what we call highly significant, so it gets 2 asterisks. If we had had a p-value in here that was past p equals 0.05, but not past p equals 0.01, we would have seen 1 asterisk, and the legend down here would have told us to look out for that.
Okay, so in our report, should we mention that our significant level is 0.05?
What you would want to say is that it was significant and you want to write the p-value. You can add in a note that it's significant at the 0.01 level if you want, but that is immediately evident to me just looking at your p-value. So just say that it's significant or not is what I would probably recommend.
Okay, got it. Thank you.
Sure. All right. Right, so you've got your R values, you've got your P values, and you know how to find which ones are significant. So report the R and P for all of those correlations, indicate which ones were significant, and when indicating how do you know, it was less than P equals 0.05, or there was an asterisk next to it. Either of those were the tell. Right, so then this question, in full sentences, describe what these correlations tell you about the relationship between these variables, what story emerges from this analysis in terms of how the four constructs included in this data relate to each other. So this is much more of a conceptual question. This is when you get to the point where you want to describe what your analysis tells us. And this is a skill I always recommend practicing. Not just reporting numbers, but verbalizing the story that the numbers tell you. So how do you do that? You look and you see what's significant, and you just want to verbalize which variables were significant. Okay, so it appears that people who are happier tend to perceive their life as more meaningful, and they have less anxiety. People with a high IQ tend to be less happy, but it has no bearing on their anxiety or meaning in life. Just take the correlations that are there and describe a little bit what emerged and what didn't. In doing so, make sure you're naming the variables themselves. So like I said, happiness was associated with anxiety and meaning in life. It's important when you're communicating about your results to adequately describe what it is the numbers tell you. So put it into the terms of the actual names of the variables themselves. Okay, so then create a scatter plot with a best fit line for all your significant correlations. What does the best fit line shape of the cloud of dots tell you? So there were, let's see, 1, 2, 3, 4 significant correlations. So you're going to want 4 scatter plots. I'll just show you one so you know how to do it. Let's take happiness and anxiety. Go to graphs, chart builder. Scatter dot. This one here, where you see the line in the preview, that's the scatter plot with best fit line. So drag that into the gallery. Drag your variables onto the axes. Doesn't matter which one is variable X and which one is variable Y. Scatter plot will look basically the same. And then, this is important, this is not your scatter plot. This is a preview, and it's not even accurate to what the actual scatter plot will look like. This is not your scatter plot. Hit OK. This is your scatter plot. Looks a little bit different from the preview, right? So make sure you hit OK to get the real thing. So like I said, you're going to do this 4 times for the 4 significant correlations, but that part of the question where it says, look at the scatter plot and tell me what it says about the correlation. Using a scatter plot to visualize a correlation lets you do a couple things. It lets you visualize the direction of the relationship. So the slope or slant of the line tells you about the direction. As you can see, that best fit line slopes downward from left to right, indicating that the more happy you are, the less anxiety you feel. The more anxiety, the less happy. That's what we call a negative correlation. As levels of one variable rise, levels of the second variable decrease. You can tell that by looking at the slant of that best fit line. The other piece that you can visualize by just looking at your scatter plot is a bit of the strength of the correlation. Key to using your scatter plot and best fit line to visualize strength of the correlation has to do with the extent to which all of these data points appear clustered closely to that best fit line. The more the data points take on a coherent linear or line-like shape, in that they're clustered and clinging quite close to this line, the stronger the relationship is. This actually is pretty strong. This is actually quite strong. There's very few data points, so even a correlation as high as -0.78, you're not seeing like perfect cohesion to the line. This is quite strong. You do see that line-like shape emerge. So that's what you can tell by looking at your scatter plot with best fit line. You can tell the direction by the slant of the line, downwards or upwards. And you can tell a little bit about the strength as well. So that'll do it. Like I said, correlations in SPSS are pretty easy, pretty straightforward. So I would recommend taking some time just to make sure you have everything written up. Make sure you have your R and P values written up for question 2. Make sure to write your verbalized interpretation for question 3 and create all of the scatter plots you need. As always, make sure to have your answers in one document and save your output at the end. You don't need to close your output window after every analysis. Just keep it in one file, and you can just save it as your lab quiz 4 output. At this point, I'm going to stop the recording and take any questions if you have them. Anyone who wants to hang out and have a check-in, just hang out. But at this point, that's all I have to walk you through lab quiz 3.